Hi, welcome back. Today we're going to be solving Advent of Code 2022 Day 2. Before we get started, I went ahead and wrote like a template file for all of these Advent of Codes. Each one of them has two parts and they all have to read in a text file. So I went ahead and made a simple main function here. This is based on yesterday's work. And I added some typing for what the input is. Now the input is different day to day, so we can set our types here, and then they'll be properly typed as the result of parse input, and then as the input to part 1 and part 2. So let's get started. The elves begin to set up camp on the beach. To decide whose tent gets to be closest to the snack storage, a giant rock, paper, scissors tournament is already in progress. Rock, paper, scissors is a game between two players. Each game contains many rounds. In each round, the players simultaneously choose one of rock, paper, or scissors using a hand shape. Then the winner for that round is selected. Rock defeats scissors, scissors defeats paper, paper defeats rock. If both players choose the same shape, the round instead ends in a draw. All right, very similar to the game we all know. Appreciative of your help yesterday, One Elf gives you an encrypted strategy guide, our puzzle input, that will be sure to help you win. The first column is what your opponent is going to play, A for rock, B for paper, C for scissors. In the second column, suddenly the elf is called away with someone's tent, to help with someone's tent. The second column you reason must be what you should play in response, X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the response must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors, plus the score of the outcome of the round. 0 if you lost, 3 if it was a draw, 6 if you won. Okay, so score is a little bit techy. You have to figure out which shape you selected and map that to an integer and then add the outcome of the round, which is based on the shape comparison. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, if you were given AY, BX, CZ, then it predicts that your opponent will choose rock and you should choose paper. This ends with a win and a score of 8, right? Because we win is 6 plus 2 for rock. Oh, 2 because you chose paper, sorry. The opponent chose rock, of course. In the second round, your opponent chooses paper and you choose rock, and this ends in a loss with a score of 1. And the third round is a draw, giving you a score of 3 plus 3. But because you chose scissors, you get 6 as a score for that round. In this example, if you were to follow the strategy guide, you would be getting a total score of 15. What would your total score be if everything goes exactly to your strategy guide? So for this problem, we're really just interpreting the input and then adding some things up. There's no real solution here. We just have to read in all of the input, compare the two values to get whether we won, lost, or draw, and then compare our value to a score. So the first thing I'm going to do is create a map of pairs of like what the opponent played versus what we played to outcomes. And then I'm also going to create a map of what we played to scores. And that way we can have a score map. We can create a score mapper. So, so our input is going to be tuples of strings. So we're going to have each tuple is going to be a pair of what our opponent played to what we played. So and our input is a list of these. So that's our input. And then we're going to have a outcome score, and this is going to be a map of each tuple. So A to Y. Well, let's sort. So A is rock, and let's start with X for rock. So this is rock, rock, and this scores 3 because it's a draw. And we can do the same thing for all the draws. So B, Y, C, Z, draw. And then we're also going to do the wins. So let's start with what is AY? A for rock versus Y for paper. Now paper beats rock, so this would be a win for us because we're playing the XYZs. So that is 6. And it's going to be the same for all of these. So BZ is going to be 6 as well. And that's going to be paper, scissors. So scissors beats paper. And then finally CX. And this is also going to be a win. That would be scissors played by the other elf versus rock, and rock beats scissors. Now we simply have to put all the losses, which is one more set. So that's A, Z. Sorry, I typed Z, but I meant A, Z. It's going to be 0. That is rock versus scissors. So since rock beats scissors, we would lose. And I'll just put all the rest in here. BX, 0, and CY is 0. And that should take up every single outcome. And if an outcome doesn't exist, well, we're handling every outcome. So we have AX, AY, AZ, BY, BZ, BX, CZ, CX, CY, and that's every outcome. And we have 3 draws, 3 wins, and 3 losses. So that's correct. Next thing we want to do is we want to make a score map for what we play. So our play score, and this is just going to have 3 entries, X, Y, and Z. And so they said 1 for rock, so X is 1, and Y 2 for paper, right? Yep, and Z 3 for scissors. So now from now on, we actually don't have to care about the whole rock, paper, scissors thing. We just have to write out our input. I wrote this tuple thing wrong, right? Yeah, that's supposed to be square braces. All right. So for each parse input, we want to create a tuple stir. So what we can do is we can just do line.split on this, and then we can cast that to a tuple. So to tuple equals lambda pair 0, pair 1. There's probably a helper function for this somewhere, but I can just use a simple little lambda function here to convert in a list of length 2 to a tuple of length 2. And so now our parse input goes into this list of tuple strings. And then for the first round, we just need to calculate the total score. So let's create a score function, score, and we're going to be scoring a single game, or round, I believe they call it. And each round is a tuple of stir to stir. And we're going to outcome with an int. And all we have to do is add the outcome score of the round plus our play score of our play, which is the round 1, being the second value in the tuple, which is our plays X, Y's, and Z's. And we just need to return that. And again, I wrote it with a parenthesis instead of, and there we go. So that should be good. I don't know why this is giving me an error. Argument cannot be assigned. I think it just doesn't know what it's talking about. We can type it. And now it will stop complaining at us. All right, good. And so for part 1, we just need to return sum of score of round for round in input. And that should be good to go. Let's grab our example input here. And we're going to create a file called example and write it. And then we'll pull up our terminal. We'll run Python day2.py, and we'll do example. And we get the value 15. Is that the correct answer? It is. So now let's grab our puzzle input And I can just open this guy up, copy it, open input file, save. And since there's an end of new line here, let's go back to our day 2 and let's just make sure that we are trimming this file just to make sure any extra new lines don't affect it. Right? Trim, is that the, no, it's strip. Strip is the trimming function in Python. My bad. All right, so now let's run it with, we can rerun it with the example, still works, rerun it with input, and now we get 9759, and we're gonna try our answer. And that is correct. Awesome, so we just added up the scores. Part 2. The elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. Okay, so we're redefining what X, Y, and Z means. So we have to throw away our code for part 1, and we'll play for part 2. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example now goes like this. In the first round, your opponent will choose rock, and you need to end the round in a draw, so you also choose rock. This gives you a score of 1. So the scoring is the same, but we need to map X, Y, and Z as a definition of how to end the round to X, Y, Z as what to play. So this is pretty fun. So instead of, what I'm going to do, so this outcome score and our play score are they're still important. And score is still important. But what we need to do is now create a function that maps, that takes a current round and decides what we're going to play. So def, and we'll just call this part 2 underscore, just to make sure we know this is part of the part 2. And we're going to say calculate, what are we going to want to call it? I would say outcomes, or maybe what to play. All right, and so we're getting a round, which is still a tuple of stir to stir. And what are we going to return? We're going to actually return another tuple of stir to stir. And these mean slightly different things. So what we're going to get is a round as defined by part 2, where X, Y, and Z means what we have to do. And then we're going to return a pair of A to X, Y, and Z, which means what we want to play. So let's, so all we have to do is look at the second value. So if for this we could create another map, right? But it's actually probably creating another map is actually easiest, because then we can just look at all of the outcomes and be sure that we made it right. And so we're going to do a what to play dict of tuple stir to stir, and we're going to outcome is a string actually, so we're going to outcome what we should be playing. And it's going to look a little weird because we're going to take in all these. We want to start with this set of keys. So this is all our input values, and we want to return what we should play. So if we have A, that means the opponent played rock, but we need to lose. So if our opponent played rock and we need to lose, we need to play scissors. Now scissors is defined as Z, so we need to return Z. All right, and let's just start with let's reorder this so we can understand it a bit. So now we have at the top here, we have everything where we need to lose. So A to Z's, B is going to be to X, and then C is going to be to Y. All right, and that's how we're going to lose. And we can confirm this because AZ is a lose. All right, and then for each of the Y's, Y means we need to draw, and these are easy because we just put out the same thing. So A maps to X, and B maps to Y, and C maps to Z. And then finally, and I'm just going to do some reordering here so it looks nice. And when we have Z, we need to win. And so A needs to map to Y, and B needs to map to Z, and C needs to map to X. And I can confirm, because when we have C and X, we can go up here and look at this, that is a win. And so Z means win, so we should have CX. And so now, when we want to calculate what to play, all we need to do is return the round 0, because what they're playing isn't changing, to what to play of round. And then our part 2 is all we have to do is call that function on each round and then calculate the score. So we can return the sum of score of part 2 calculate what to play of the round for the round in input. All right, and that should be everything. I believe we're ready to go. So let's pull this up and run it on the example, and we get 12. What is the correct answer? The correct answer is 12. All right, so pretty sure we did it correctly. Let's run it on the input, calculate, copy that value, and submit. That's right, we got the gold answer, or gold star. So we did it. We were able to map 2 different definitions for the input. I didn't like that I used the same values when they changed the meaning of the X, Y, and Z. I didn't like that I just mapped them to X, Y, and Z. This was, of course, the fastest way to complete the problem, which is kind of the goal with these coding challenges. But long term, I wouldn't, in these cases, X, Y, and Z means 2 different things in the 2 different problems. So this mapping is really hard to figure out what it means. So you would need a lot of documentation or comments to understand it. What I would prefer to do is actually map in part 1, I probably should have mapped X, Y, and Z back to ABC. And then in part 2, I can map X, Y, Z to ABC. But of course, I didn't know what part 2 was going to be when we had part 1, so we wrote it the way it was. This is very similar to a lot of things where you just don't understand what you're writing when you start writing. But we got it done relatively quickly, so I'm glad about that. And I hope you guys enjoyed, and I'll see you tomorrow.